Good morning, everybody. And for the sake of being audible, I'll take off my mask. So it's not because we are not observing COVID protocols. Ladies and gentlemen, it gives me great pleasure to welcome everybody to the Kagiso Trust Maths Symposium, the inaugural one, a very auspicious occasion. And before I start, let me acknowledge a few people. We appreciate you joining us online as well. We're coming to you live from R40 at the University of Limpopo in Mankweng. And I must say, my alma mater, if you'll engage me. The last time I was in this hall was 30 years ago. So it's a very, very happy and emotional reunion. But let me acknowledge the chair of Kagiso Trust, Mem Manko Ninsaba, who is with us here. And let me acknowledge also Programs Committee Chair from Kagiso Trust and a trustee, Dean Zo Neutalu. Again, another always very emotional reunion when I see this man here. Let me acknowledge our host from the University of Limpopo, Registrar Professor Kwena Masha, right here next to me. Let me also acknowledge the CEO of Kagiso Trust. She's in the audience here at R40. I know we are joined by a lot of the patrons of Kagiso Trust online. We may acknowledge them as we go along as they indicate that they have joined us. We have lots of Kagiso Trust Exco, members of the Exco here, including the team that organized this event. We also have with us that we want to acknowledge members of the staff from the University of Limpopo. Some of them are speakers on the panel, some are in the audience, but we appreciate the fact that you hosted us here at this lovely campus. We also want to welcome our speakers, our esteemed speakers, that you will hear from, each one of them bringing something unique, but also very complimentary to not only the objectives of this event, but to the spirit of what Kagiso Trust stands for and has stood for over the years, as well as what the University of Limpopo is proudly being associated with here today. We have all of you delegates joining us online, so we appreciate your presence. Those of you who are with us at R40 at the University of Limpopo, but most of you who are joining us online from everywhere in the world. My name is Victor Homweswana, and as an alumna of this university, I'm very proud and honored to host you again for the Kagiso Trust Maths Symposium. By the way, because we are online, what's important is that you should know the hashtag that you must use. And I don't have to educate you about hashtag, but it's important, whatever you tweet, whatever you put on Facebook has to have the hashtag KT Maths Symposium. Hashtag KT Maths Symposium. It's one word, so don't space anything. And every time you tweet, please tag at Kagiso_trust. At Kagiso_trust. And also tag at UL Varsity. At UL Varsity is a partnership that we want to profile. If you're on Facebook, also find Kagiso Trust and tag them, and tag University of Limpopo if you're on Facebook. So the hashtag, please, one more time, is hashtag KT Maths Symposium, and tag at Kagiso_trust and at UL Varsity. The theme of this symposium is Maths for the 21st Century and Beyond. And the subtitle is Improving Mathematics, Teaching and Learning. Maths for the 21st Century and Beyond, Improving Mathematics, Teaching and Learning. It is part of the Kagiso Trust Education Program District Whole School Development, and it seeks to improve particularly the performance at schools, those schools that are struggling. You can say underperforming schools, you can say poorly performing schools, but schools that are not performing as well as they could and should, And every school should and could be able to perform very well. But those schools are the schools that seek the intervention the most. And Kagiso Trust's education program under the district whole school development model, and that whole school is very important because mathematics is part of the curriculum. So when you're developing a school, you can't just develop mathematics. But today we are focusing on mathematics because mathematics is a special tool. It's a special key that can unlock many doors. So the key focus here today is performance in mathematics. But remember the whole school development, because it's only when you fit the performance in mathematics into the whole school development that it makes sense. So the purpose is to get that in-depth analysis and understanding of the performance drivers for mathematics. Every subject, every learning area has drivers. So today we are hoping that the speakers and the panel members and you, the delegates joining us online, will be able to contribute and share some of your insights, some of your expertise, some of the things that you've been doing in your particular capacity as either an educator, as a learner, as a lecturer, as a professor, as a researcher, or just as a stakeholder, like Kagiso Trust, who's interested in mathematics and particularly enhancing the performance. How are we going to do that? We made sure that the members of this panel, the speakers at this symposium, are experts, either as researchers, as academics, and they have done a lot of work over the years. So they are not sharing theory only, they're sharing theory and practice. When you combine theory and practice, you'll get something. And hopefully at the end of this and beyond, we will be able to give input and give feedback to the policymakers and people who run the education of our country. Purpose being, knowledge is knowledge only if it leads to a change in behavior, it leads to better performance. I hope by the end of this, and as I close my opening remarks, I'm hoping that by the end of this symposium, there will be answers to one simple question. Can mathematics be for everybody? I am a teacher, former teacher, and I went to school. Mathematics was always seen as something that only a few people can do, which is very strange because it doesn't matter whether you think you're mathematically inclined or not. Every time you speak, there are numbers in your speech. We write poetry and poems are all about numbers. How do I love thee? Let me count the ways. Every time you're comparing, every time you walk out of your room, you're counting. Everything we do, with timekeeping, everything we do is about numbers. But somehow when we come to mathematics, it suddenly looks like it's something only a few people should be able to understand. So today, let's answer that question. Is mathematics for everybody? Can everybody learn the subject and master it? Because we know it is necessary. So speakers, if you can answer that question for me, I'll be the happiest person. And if I'm happy, I tell you, I'll spread the gospel like no one you have seen, but you've got to answer and convince me. So ladies and gentlemen, we have a very packed program. It's going to go on until 12. We're hoping that you'll be able to stay with us throughout because every item here is unique. I will not go through the program, but we have members from the Kagiso Trust, from the University of Limpopo, and we have got experts, including Professor Mercy Kazima, who's joining us from the University of Malawi. She's a mathematics professor. She's joining us from a town called Zomba in the south of Malawi, not far from Lilongwe and Blantyre, but it's quite far if you have to travel from South Africa. So she's going to be joining us. We're also going to be joined online by Daniel Hoos, who's the South Africa 2020 top mathematics learner. He's joining us from the Western Cape. So we will promise and deliver that this is going to be a very exciting program. But before we start, we are at the University of Limpopo, so let's be giving acknowledgement to the university by asking mathematician and registrar of the University of Limpopo, Professor Kwena Masha, to say a few words of welcome. Prof.
Thanks, Program Director Ndate Victor Khumbuye-Swana. It is always a privilege and an honor to have you amongst us here. Let me also take this time to acknowledge our partners, Kagiso Trust, and starting with the Kagiso Trust Board Chairperson.
Microphone is on, please. Somebody's microphone is on. It should only be Professor Masha's mic that's on. Please check your mic. We are having an echo. Sorry, Prof. Please proceed.
Thank you very much. I was saying, let me take this time to acknowledge our partners, in particular the Kagiso Trust Board Chairperson, May Mangone Nshaba, and Kagiso Trust CEO, May Mangodi Muitse, Kagiso Trust Programs Committee Chairperson, Tate Dean Zone Dalu, our speakers, Professor Kabelo Chweni, Prof. Messi Kasima, Dr. Kangelani Suvia, and Brother Daniel Hose. Good morning, colleagues. And let me also acknowledge all participants in this inaugural International Mathematics Symposium across both physical and visual platforms. Professor Makho Makhalong, our Vice Chancellor, and the Principal, together with his entire executive management, would really like to warmly welcome you to this magnificent institution. We hope that today will take our partnership further. The University of Limpopo is really privileged to be partnering with Kagiso Trust. We have a lot in terms of shared history. We have a lot in terms of our desire to advance the teaching and learning of mathematics. When Kagiso Trust was founded in 1985, the University of Limpopo, at that time, University of the North, was training mathematics teachers in a very, perhaps can I say, scanty way, in that you had all the training basically taking place in cognate departments, and then they will come into the School of Education for what we call the method, and they will focus on the method of teaching mathematics. That was then, and it was very tough. There were very few students going through that. But over time, the university's desire and appetite to make serious inroad into this area was conceptualized and developed. In the late 90s, the university established the Department of Mathematics, Science and Technology Education that is today hosting us. At the time, there was a serious capacity challenge as there were very few individuals who were trained at doctoral level, especially in the country. However, the university's determination to make a significant contribution in MSTE, that's Math, Science and Technology Education, was never dented. And just like with master's training, most of us had to get outside of the country to pursue our doctoral studies. Chairperson, you will be interested to know that I also met one of our speakers, Prof. Messi Pakela. We were doing the master's together at the University of Leeds. So at the university, that dream, that commitment to train mathematics teachers continued. And today we're talking about DIMSTED. This is the department that is hosting us, having an annual intake of more than 300 students across all its programs. And we also have more than 35 staff members from the period where we had one at some stage. And now we are at 35. So you can see the commitment and the growth that has since happened. So having done that, having achieved the challenge of capacity, we now refocusing, we're now focusing more and more on what it means to train mathematics, science, and technology teachers in the context and in the continent of Africa. This is very important. So it's no longer just what is that can be done to improve the teaching and learning of mathematics. But it is the question of how can we also acknowledge that we are doing the same from an African continent and teaching African children. So there are now main questions that the department is pursuing, and I'll just highlight just a few of them. I know Dr. Prof. Chweni will also be covering some, and others will get those from also the other members of the department. But one of the big questions is, what does it mean to teach students, especially African students, in an African university whose vision is to find solutions for Africa? It's a big question. We have to dig deep to deal with that question. And again, we're asking, what are genuine African support structures that should be provided to African students in an African university that pursues African solutions? We know that, as you were saying in your opening remarks, that we need to ensure that everybody can learn mathematics. But going with that is, how do we support them to learn mathematics in a very efficient way? So this is where we're saying and asking the question, what are the support structures that acknowledges that we're doing this from the African perspective? What is that we can put in place? So this university is pursuing that also, from slightly outside the department, of course, but together with the department. And there is currently a student support system that is called Valditi. I know that most of you will know what Valditi is. In our cultures, there is the school, our African traditional schools, and those who are looking after those schools are called Valditi. And Valditi goes beyond that kind of school and into our society. That's why when you're doing something, you also say, in honor of Valditi, so I won't go deep into this because I won't perform better than my Muditi. So we're having 2 PhDs projects that are coming through that. They are still in their early stages to say we need to harness our knowledge systems so that we bring those into the teaching and learning of mathematics. Again, we ask, in the context of African thought systems, what does it mean to embody a mathematics teacher? What is a mathematics teacher in the context of an African knowledge system? And we've been asking a particular question to say, is an individual sufficient? Is an individual having sufficient capacity to embody a mathematics that is there today? And the answer to that question is very challenging, and we feel like an individual is not sufficient. So it doesn't help to do research on whether any individual have sufficient capacity. We know individuals don't have sufficient capacity. I've trained up to PhD level, but I'm still not sufficient to embody a mathematics teacher. So what then should embody a mathematics teacher? This is one of the questions that we are asking. And we have already graduated a PhD student here and a master student, and there is also another one who is going through training, who's looking into this area, because we think that if we find a solution there, then we'll be better positioned to bring in African issues into the training and teaching of mathematics. The last question that we also ask is, what constitutes text, or especially mathematics text, in an African setting? Is text only in a textbook, or is mathematics text all around us? And Chairperson, you said, if everybody can do maths, and if I'm working out, there is maths, if I'm doing this. So the question is, what is text? What constitutes text for mathematics? We need to look at that and bring it in. That's why, among other projects that we had the Muruba or Marabaraba project, where an honor student was looking into that and decoding the mathematics that is involved. And again, if you are coming from the farms, you see the central pivot irrigation systems, the water going around and round and round. And we had a master student looking into that to say, what kind of mathematics can be extracted from there? The idea is what constitutes mathematics and where is it? And how do we bring it into accessible, to make it much accessible to students and to everybody? So we are addressing those questions as University of Limpopo. That's why we are excited to have this partnership. These are just few projects that we have, and they are contributing to what we think should be pursued as we are addressing the improvement of teaching and learning. In closing, let me say that today is not me who's supposed to be presenting these ideas. We have speakers here. My role was to welcome you to this glorious occasion. Let me just do that and say, ladies and gentlemen, welcome to this 2021 edition of this joint venture of Kagiso Trust and the University of Limpopo. Welcome to the inaugural International Mathematics Symposium. Have a fruitful engagement. We're looking forward to be reaping from this. We hope in the nearby future, the fruits that will be coming out of this will help us sustain our training and also sustain the interest of those students who are still to come and be part of this huge dream of making an African child be at home at the University of Limpopo. Thank you very much and wish you the best.
Yes, you may actually applaud. Actually, you should applaud. And let me tell you why you should applaud. I'm a country boy through and through. And I say this all the time, just to make sure people understand this. I grew up in a village. I was born and raised in a village in this Limpopo province. A place that nobody knows about. We always joke that even if you lost your way, you would not find yourself in my village. It's just that difficult to, even if you lose your way, you can't end up there. So it's just, sorry, I need to hear that the university is doing Moraba, a game that I grew up playing and thinking it was a symbol of illiteracy. To know that my university in this province has acknowledged Baditi as a model, a role, a symbolic role model to incorporate into higher learning is reassuring. That Prof. Masha, I know you were a student here when I was a student, yeah. But you are really educated. They always say somebody's learned, as in they can do fancy mathematics. But when you are educated, as in you understand the context, that knowledge is us. There was a day when the subject wasn't called mathematics, and somebody developed it. So for it to develop and be so far away from us is a disaster. But it sounds like you found a way, you've come the full circle in saying, let's bring it back to the very people that brought us up. It's that kind of humility that we need to stick to and remember. I appreciate my alma mater, and I appreciate you, Prof, for what you're going to be talking to us about. And I hope that Professor Chweni, Kabelo Chweni, will share some of those insights as well. It's good to see. Let's move on to the next speaker. And because we are pressed for time, I will ask you to please look at his CV. It's a very illustrious CV, very impressive. Once again, as a former teacher, Dean Zavutalo, I get humbled when I meet a young man from South Africa whose expertise is mathematics. Because in South Africa today, we're talking gender-based violence. And often when we talk about men, it's in that context. So to see young men like this, especially the one that's going to speak now, talking a subject and being invited to New York and to India to talk about a subject that's so difficult for most of us to comprehend is humbling. So from the Global Education Network, I want you to please welcome the 2019 Global Teacher Award winner. He's none other than Dr. Kangelani Sibia. He's going to talk to us about the power of creative strategies to improve the teaching and learning of mathematics. Dr. Sivia, we are all yours. And as they would say in KZN, where you're from, Ndaba. Please applaud.
Program Director, thank you so much for the introduction. Well, in fact, I don't know where to start, but let me say, firstly, greet all the protocols observed. Here, I'm very humbled to say to be invited, and I'm very grateful to say, in fact, I was not like expecting to be one of the speaker in this wonderful event. So I'm very grateful, and whenever you plan to have any session, please, I'll be always available then to be a part. Then, especially in this event whereby we're talking about this subject, which is mathematics, the problem that we are facing as a country is that our kids, or even teachers, us as teachers, we always have that stigma of saying this subject basically is difficult, of which is not the case, according to my understanding, of which that is what I'm going to explain, to say why I'm saying mathematics, it's a very easy subject. Then what I normally do when I teach my kids, the first thing that I normally do when I get to class is to make it a point that I allow them to write their visions, to have their choices to say. I normally allow them to go up to 3 choices. For an example, to say if one wants to be a doctor, then we must discuss that as early as on the first day, to say, no, if you want to be a doctor, next to your first choice, obviously you have to write the symbol that you have to score, to say, if you want to be a doctor, you need level A in mathematics. You need level, which is level 7, which is symbol A to say. And if you want to be an engineer, you also need level 7 to say. And that obviously assists them whenever they are studying, to say, no, at the end of the day, I want to be a doctor. So basically, this is what I must achieve. Because in most of cases, like myself, I'm also a tutor, and I also run an upgrading center. So I always face a problem whereby the kids would say, no, I wanted to be a doctor, but now I have level 5. Can I be a doctor if I have level 5 in mathematics? Of which it's very impossible. So that's why I'm saying we have to always remind them of their choices while teaching them, so as we can run away from this stigma of saying mathematics is a challenging subject to say, which means as teachers, we have to always do career guidance on our kids. We remind them of their choices to say. And what I normally do, because in order to make sure that I work against this stigma, I always explain to them how easy it is to pass mathematics. For an example, let me make an example of paper 1. In mathematics, if we talk about paper 1, is out of 150 marks, of which it's plus or minus 12 questions there. So of which, if one is to pass mathematics, he or she need to score about 45 marks, which is 45 over 150, which would obviously give you 30%. So what I normally say to them, if in a paper you have like 12 questions, let's say in each question you only score 4 marks. So question 1, 4 marks, question 2, 4, question 3, 4, up to question 12. So basically when I say 4 times 12, that is 48. So which means it's very impossible for someone to fail mathematics whereby you only need 4 marks in a question. So basically what I normally do is to say no one must fail mathematics or can fail mathematics if you only need 4 marks in a question. If, for example, you have a problem with question 12, for example, but in question 1, if in question 1 you can simply score like 8 marks to say, there is no need of writing question 12 because you already have 4 marks which you collected from question 1. And again, if question 2, you can also take 8 marks there. You can even jump like 3 questions or 4 questions. So it's very easy to pass mathematics because we are saying you only need 4 marks per question. However, if you want to go to the university, you have obviously to move from these 4 marks, then you move to 6 marks per question. So if you can always target that to say per question, let me target how much in a question. So it would be easy for anyone to pass mathematics. That's why I'm saying mathematics is a very easy subject. It's very easy to pass subject to say, of which we have to keep on reminding them that. However, as I said that this problem of the stigma of saying mathematics is difficult is not only for, which is in learners, even us as teachers. I remember when I was doing grade 12, back it was 2006, my teacher, in fact, by then there was higher grade and standard grade. Then my teacher, when he came to the class for the first time, he said, no, we are expected, in fact, to choose between higher grade and standard grade. But then the teacher came and said, no, because here in the school, in fact, my school is down there in KZN, Josini, that is a deep rural area. So my school was deeply failing mathematics, but now I'm happy because each and every term I go there. And last year they scored 100% because we normally go there and assist now, of which is what is important to plow back, to go back to your community. Then my teacher said, no, because the school is failing, no one must take what higher grade. So we have to all, in fact, we were expected to take standard grade. But then I said to my teacher, no, I don't want to do or want to take maths in standard grade, but I want higher grade. Then he said, no, if you decide to take maths in higher grade, you'll be on your own. So which means you have to teach yourself because I won't be having time to teach standard grade and higher grade. I don't know what was wrong then with my teacher. However, I decided to say, no, I would go for higher grade. Then what I did there, of which I'm now sharing the study strategies, tips of how to study, especially for kids. We decided to create some group studies. We divided our class. In fact, we were plus or minus 40. Then we divided ourselves into group of 5. That is where then we were assisting each other, of which what we call peer tutoring. So then I was having like 10 groups whereby we choose one learner there to assist, especially those who were trying by then. So then that is assisted as a lot, which means the peer education or the peer tutoring, it's very important because that says even if the teacher is not there, but then we were able to assist one another. And at the end of the day, I managed to got level 7 in mathematics and also in physics with no teacher who was assisting us, because we also have that problem whereby our learners say, no, I'm failing mathematics because of my teacher. My teacher cannot teach me properly, of which is not the case. Even on your own, you can teach yourself, you can consult different textbooks, you can teach one another in small groups. That is what is important. And you can obviously use different past papers, of which we also have a problem there when I'm talking about the use of past papers, because our kids, what they normally do when they use the past paper, they just study the past paper as if it would be something that will come up in the test, of which I always tell them to say, no, if you use the past paper, what we have to do is to identify the skills that is needed in a question. So which means when you are doing any past paper, you don't have to expect that question to come, but then you have to look at the skill that is needed. So if, for example, you are preparing yourself for the exam, you only need 3 past papers, for example. You have to do question 1 from 2020 past paper, 2019, 2018. Then if you look at the question 1, you have to look at the skills that is needed across these 3 questions. So there is no need of doing all the past papers, because we have the problem of our kids wanting to do all the past papers, of which when the exam comes, there will be nothing obviously coming from the past paper. Basically, what is important is to identify the skill that is needed in each question. question. For example, if you look at question 1 in mathematics, 1.1.1, basically you need to factorize there. It's either you take out a common factor, you simply open the bracket, you factorize. But when you go to 1.1.2, that is where you are expected to use quadratic formula. So basically that is what is in fact supposed to do when they are using past papers, not doing past papers as if it would be something that would come up in the exam. So basically they need to identify skills that are needed in each question. And now trying to answer your question, Baba, Program Director, in fact, what I believe in is that if we want to change the stigma of this mathematics, we have to change the way in which we teach mathematics. Which means I'm now talking about the teaching method. Even though I have different approaches when I'm teaching, others they would say, no, doctor, you normally sing, but then I'm not good in singing. And then I would say to them, no, you don't have to sing in each and every day when you teach. And obviously when you are in a class environment, let's say there is grade 12A or next door there is grade 12B, for example, then obviously if you can sing in this class while others they are studying, obviously you disturb them. So that means singing, you cannot sing while you are teaching, but then you can only sing during extra classes or when you cannot disturb others, for example. Then what I normally do in my teaching, the first thing that I do, I normally demonstrate when I teach, because our kids, they like demonstrations. Let me make an example. When we talk about paper 1, that's mathematics, I normally use my hands when I'm teaching like topic like functions. Let me make an example when we talk about the straight line. When we talk about the straight line, there is a gradient there. There is a positive gradient, there is a negative gradient. Then I always tell my kids to say, no, my right hand, it will be always tell me about something which is positive. Then the left, it will be something negative. So which means if the gradient is positive, I can simply draw it using my right hand, that I'm drawing something which is positive. So which means if the line is like this, that means if I can be asked to calculate the gradient, obviously the gradient there will be positive because I'm using right. Then if I can draw the line that is given using my left, obvious, that means the gradient there will be what? Will be negative because my left hand is always what? It's always negative. And again, if we look at calculus, we talk about the shape of the graph. When we look at, when I talk about the calculus to say the shape, our teachers normally, or us as teachers, we normally say the shape, if A is positive, would be something like this. You see, if you are trying to draw something like this, or if our A is less than 0, it would be something also, which means this is more than something like, which is more than just the same. However, if I say, if A is positive, then that means I would simply put my right hand up, that indicating that now I'm talking about the A, which is what? Which is positive, which means the shape will be something like this. So even if they are writing the exam, question ask them to draw the graph, they would say, oh, wow, my A is positive. Then they would indicate something like this because the right is always positive. Then they would draw the shape. And obviously, if my A is negative, the shape would be something like this, which means now I'm talking about the value of A, which is negative. So basically that is what I normally do. Even if I'm teaching theorems, there is theorem 1 of which is nuclear geometry, because that is a very chapter which we believe is a one which is causing disaster in mathematics. But then that is the very easiest one because there are a lot of demonstrations there. For example, you talk about theorem 1, the theorem 1 normally says line from the center bisect the chord. So then if you demonstrate that one, I simply use my hands to say, if I'm putting something like this, then I would say this is a center. Obviously, this line bisects this line, which means this length, the length from here to here is equal to the length from here to here. So that is theorem 1, which says line from the center bisect the what? The chord. So even if they are writing the exam, they would simply indicate to say, wow, I can see theorem 1 here, which says line from the center bisect the what? The chord. So that is basically what I normally do in order to make sure that they enjoy mathematics and they see mathematics funny. Even if we talk about theorem 2, which says line from the center is twice Okay, angle at the center is twice angle at circumference. So I allow them to do that while I'm in class to say, no, can you do it? Then by saying line angle at the center is twice angle at circumference. So I always make it a point that they demonstrate so as they won't obviously forget. And I also relate mathematics to whatever they are doing, even if I can stand like this. And assuming that this is a diameter, obviously, if I can say this is a diameter, the angle subtended by a diameter, obviously, is 90 degrees. So then, which means even if the person can stand here, then you can obviously identify theorems there, because we are saying angle subtended by a diameter is 90 degrees. And again, if I can also do this, then there is 90 degrees here, which means if I'm adding these two angles, they would add up to 280, of which we are now talking about the theorems, which says opposite angles of a cyclic quad are supplementary, which means they are equal to 180 degrees. So which means mathematics is everywhere. Even if somebody can walk here, we can see the acute angle, the angle which is between between 0 and 90 degrees, which means there is mathematics everywhere. And even if I can stand here, obviously I'll be perpendicular to the floor, of which there is also mathematics. So why are we saying mathematics is difficult? So then there is no need basically of saying mathematics is difficult. Even if I'm greeting them, I don't say hi when I'm talking to them. I normally allow them to use this language that they know. When I say hi, no, I don't do that. I say, if they say hi, if we say this finger, this one, these two are parallel, which means this gradient is equal to this one. And this one, they are perpendicular to each other. So which means if they say hi, no, they don't say hi, they say be parallel and perpendicular, even the way in which we greet one another. So so even the way in which they greet one another, it has to be something which has to do with mathematics. So then when I meet them in town, they don't say hi, sir. No, they say be parallel and perpendicular. So that is that is what I normally do. Right. And also when I also relate my teaching to soccer. You see, when you see the sign for Memorial Sundowns, for example, it would be something like this, which is 7. Yes. Then yes, I say to them, no, there is mathematics there. This finger is perpendicular to this, which means the angle there is 90 degrees. The product of these two lines is equal to -1. So when they see the sign of Orlando, of Memorial Sundowns, obviously they can see mathematics there, which means the two lines, there is angle there, which is 90 degrees. Obviously, if I can construct here, there is a right angle triangle, I can apply Pythagoras theorem, and I can also use trig ratios there. So mathematics is everywhere. Even if we talk about Orlando Pirates, the sign is like this. But then there's mathematics there, because this angle which is here is equal to this one, which is vertical opposite angles. There's mathematics there. And also this one is equal to this. And if you add all the angles around, they add up to 310 That is revolution. So then why are we saying mathematics is difficult? Then if we talk about Kaiser chips, there's this sign for Kaiser chips. Obviously, if we say this is a line, this is an angle, this is a line. Now there is side angle, side, which means the edge here is what is included. There is cosine rule, there is area rule that you can apply there. So mathematics is everywhere. Even in soccer, you can see mathematics. So that is what I normally tell them to say, no, you cannot fail mathematics. It's everywhere. And again, I know that our kids like music, they like singing. So that is what I normally do. I normally sing, if for example, there is a definition, let me talk about physics. If there is a definition, there's a principle that they have to state. We just take any tune of the song that is trending, and then we put the definition there. But let me talk about mathematics. We know there is this Euclidean geometry, of which I said is a chapter which is challenging. And for example, one of the songs, I would just take 2 of my songs that I normally use when I'm teaching this subject. There is this thing which says, when we talk about parallel lines, we say if there are 2 parallel lines, there is alternating, there is corresponding, there is co-interior. However, the 2 angles cannot correspond, not unless the 2 lines are parallel. Even if we are in a marking center, if there is no parallel lines indicated, then we forfeit, the child will forfeit 1 mark there. So they must indicate the 2 lines which are parallel. So then there is this song. I'm sure you won't understand because I'm coming from KZN, but then I'm just making an example. They like to sing the song which says, then I'll just sing shortly. The song says, then I change it from there, and then I put mathematics by saying, here alternator, ngobe parallel. Here alternate, here alternate, alternator, ngobe parallel. Here correspond, correspond, ngobe parallel. Here co-inter, ngobe parallel. So obviously, if you do that, they won't even forget when the exam starts. Yeah, so then there are so many songs. When you talk about calculus, there are steps that they must follow when calculating the turning point. To say when we are looking for the turning point, you derive, let derivative be 0, you substitute into original equation. We also saying that by saying any turning point when we are deriver equal to 0, substitute back to the original. Any turning point when we are deriver equal to 0, substitute back to the original. So obviously they won't forget. If they are required to calculate the turning point, they would follow the steps. In fact, while writing, they would be singing inside, while writing the steps, then of calculating the turning point. So basically, that is what I normally do when I'm teaching mathematics. However, in my conclusion, what I always say when I'm talking to teachers about the subject that we are teaching, the first thing is the one which I've indicated, to say, let's try to change our teaching. Let's make mathematics be an enjoyable subject. Let's try to make our mathematics be funny. Even myself, when my kids, they are free, then they make it a point that they say, where is Prof? They normally call me Prof. Where is Prof? Then I want Prof to come and teach us because they are free. So they enjoy mathematics. They know that when I come to the class, it will be nice, then they would enjoy my lesson. So that's why I'm saying, as teachers, we have to try to come up to develop or to have or to come up with strategies or any funny method to say. So as a teacher, you have to be innovative. Obviously, you have to be creative. So that is what we normally do. And again, when we are teaching this subject, we have to always use our CAPS document. Obviously use our exam guideline, because in most of the time we normally as teachers focus on the past papers, forgetting of what we call exam guidelines. That's why we ended up saying, no, the paper of 2019 or 2020 was difficult, of which it was not at all, because the examiner there used what we call exam guidelines. So we have to always, when we are teaching, use exam guideline, the report, the analytic report that is released immediately after exam, which is identifying the problem or the misconception that our learners normally do. And we have to obviously keep on reminding of their choices. So as they won't forget, they would know that at the end of the day, I want to be a doctor. So which means I have to work very hard. And another problem that is there is of the fact that we, as different schools, or most of the schools, they focus on grade 12, of which to me, the focus should be in grade 9. The expert educators must be put there in grade 9 in order to build the basics there, because we normally, I normally receive so many calls from parents to say, I don't know what happened to my child. While he or she was in grade 7, mathematics was something around about 96, but now he's in high school. It's getting something plus or minus 20%. I don't know what's wrong. So that's why I always say, if I were to be appointed to be a minister, I can obviously make it a point that grade 7, they write a common exam. So as we know exactly the kids that we are receiving from grade 7, because they are coming with the high marks of which when they are here, then in grade 8, you can see that, no, there is a problem here, which means the problem not started here in grade 8, but it started back in grade 7. So that is, to me, what we have to focus on. Anyway, one of the key methods that I normally use in order to make sure that my kids normally perform or always perform, I always give them informal test, but a very short one of plus or minus 15, plus or minus 10, which means when they are giving them the test, it would be a formal test, it will be not something which is plus or minus 50, because why 10? Because I want to do what we call item analysis, because when you do item analysis, it will be easy for you to organize extra classes so as to address those items that we have analyzed. So that's why I'm saying there is no need of keep on organizing extra classes, just say extra classes, morning classes, afternoon classes, Saturday classes, but you have to only organize that after you have the item analysis, and you have to only address those items, and it should not have include all of them. So you have to divide them according to your item analysis. Then thank you so much, Program Director. Thank you.
All right, you have to applaud. You have to applaud. I've never heard of a maths teacher. I've never looked for my maths teacher. No, we don't look for maths teachers. We walk away from maths teachers. We make sure they don't find you. So to have learners looking for you is something commendable. And as Madam Chair, if you just think about it, this is a young South African man. Once again, I will emphasize man, because that's the demographic we are struggling with. A young South African man from a rural province. To find that he has made mathematics fun, he has taken Zulu culture and made it part of teaching mathematics. To find that he has found rhythm in everything. Okay, you were very careful to not get too much into soccer, because you can be very in danger, Dean, I'll tell you, in South Africa. But to think that you even made fun of teams that are struggling, some of them are doing well, some of them are, and you bring them all into the teaching. Because remember, nobody's going to forget the score from the weekend match. Nobody's going to forget how much they lost by. Nobody's going to. So to know that you're doing this is just amazing. Just listen to what people are saying on Twitter, on social media. There is a comment from Teresa Vivian Muilo on Facebook saying, can teachers change the narrative about mathematics and make it fun, lit, cool? And can I even go on to say sexy? It would be interesting to get the views, but he has already answered Teresa. He says they grid, they say they parallel, they are perpendicular. And that's it. When you find something to. Sam Ramez is asking, to what extent can pure and applied mathematics be used to solve or model challenges that we currently face in mathematics education? Once again, I think you addressed that, but just so I don't deny you the chance to just briefly, they're saying, to what extent can pure and applied mathematics be used to solve or model challenges that we currently face in mathematics education? First of all, do you perpendicular and parallel that question? Yeah. Or is it just flying over your head?
Can you come again with that?
Yeah, the question is,
to ask the last, I mean, I'm sure.
They say, to what extent can pure and applied mathematics be used to solve or model challenges that we face in mathematics education? I don't think I understand the question. It's Sam Ramez on Twitter, but you're the guy who figured out this mathematics thing.
Yeah.
You can hook us up with a good answer there.
Yeah, in fact, I'm trying to understand the question.
Okay.
To me, it's not clear.
No, it's okay. So what I will ask is, Sam Ramez, I'm sure you're still online. What I'm going to do is I'm going to take the next speaker, but when I take the questions from the next speaker, I will still come back. So hopefully somebody from Kagiso Trust can tweet Sam Ramez, just clarify the question. You see, he's a mathematician probably, so he's asking it in a very complex language. So please, Sam, just rephrase your question. And by the way, do not be shy to use the question and answer chat function. We are on Facebook Live, we are on Twitter, and we are also using the Zoom meeting. There's a chat function that you can be able. I'll be checking your questions as I go along. And by the way, let me acknowledge also the patrons. One of our patrons we've joined online. We appreciate your presence, Bongiwe Njobe, for joining us. She's our patron, and the two trustees also logged on. Madam Chair, you'll know, Tabiso Ratsuma and Gulam Abubakar. So we appreciate that not only is the staff of Kagiso Trust involved in this, but also the trustees and the patrons. As we know, we already have one patron here in Din Navutalu in our meeting. The chair of the programs committee chair. He's a trustee, not a patron. But yeah, we appreciate you joining us. Let's move on to the next speaker now. And the next speaker is joining us, like I said, from the Great Lakes region. So she's going to be joining us online via the link. And she is none other than the professor of mathematics at the University of Malawi. And like I said, they have 3 campuses. I didn't know that in Malawi. And one is in Blantyre, I think the other one is in Lilongwe, but she's joining us from Zomba, which is one of the towns of Malawi in the south of the country. She's going to be focusing on how to improve mathematics teacher education to enhance learner performance in mathematics. And here's a very interesting dimension, Dean Nautalu, the effect of African mother tongue in teaching. We've already heard from Dr. Severe how you can use mathematics and the culture and be able to teach at the same time. People can appreciate their culture, so they don't feel like if you're speaking isiZulu or Chivenda or Chitsonga, you cannot learn mathematics. So there you have it. Professor Messi Kazima, welcome and thank you very much from Zomba. I will step off and we enjoy your presentations. After this, in the audience online, radio questions so that the two of them can take them when Professor Kazima is done. Thank you very much.
Good morning. May I just check if you can see my slides?
We can see your site, Professor. We can see your slide.
Can you see my presentation? I'm sharing it now.
Yes, we can.
Okay.
Thank you.
Thank you. Thank you for the kind introduction. As she has said, my name is Messi Kazima from the University of Malawi. Thank you for inviting me to be part of this symposium. My talk, as you can see, is how to improve mathematics teacher education to enhance learner performance in mathematics and the effect of mother tongue in learning mathematics. An outline of my presentation is as follows. The background, then I'll look at mathematics teacher education. Here I'll focus on lessons from research. Then I'll move on to mother tongue and learning mathematics. Again, I'll focus on lessons from research. Then I'll link mother tongue and mathematics education. And finally, I'll give my concluding remarks. So as a background, many countries have concerns about low achievement of students in mathematics at all school levels. Malawi and South Africa are also the countries who are concerned about low achievement. And this low achievement is usually seen from the national assessments and also from international assessments. For example, the Southern and Eastern Africa Consortium for Monitoring Education Quality, what is commonly known as SACMIC. SACMIC reveals that many children perform below the curriculum expectation of their level. So for example, in Malawi, SACMIC has shown that grade 6 children perform below grade 4 level. I should say here that SACMIC assesses grade 6 children in all the countries which participate. So this low performance suggests that the teaching of mathematics is not being effective. For those that are not familiar with SACMIC, I'll just show the first three SACMIC briefly. SACMIC aims at helping the participating countries see the potential of their children, how well they are doing according to the curriculum expectations. And it also helps us to compare across countries and learn from each other. So one of the things that they do is also we can rank them according to the highest performing country to the lowest performing country. And this is just to let us know how well we're doing in comparison to the other countries in the region. As you can see here, Malawi is at the bottom. South Africa is not so bad, but still not good enough. Over the years, South Africa has been improving, but Malawi has remained at the bottom. But still, from educators in South Africa, is still at the place where South Africa wants to be. These are the old SACMIC. There's a new SACMIC, more recent one, 2019, but I do not have the data for that. And by showing you this, I was showing that this is one of the reasons that we are concerned about students' achievement in mathematics. It has been well established that effective teaching and effective learning in schools in mathematics depend on a number of factors. There are factors about the teacher, it's about the language, the resources that are available for teaching, the class size, and so on. However, research has shown that among all these factors which affect teaching and learning, the most important factor is the teacher. This means that even if you have all the other things, the resources, a good class size, and so on, if the teacher is not well prepared, then achievement will still be low. Research has also shown us that good teachers can handle all the other factors better than poorly prepared teachers. So the teacher is indeed the main factor. Therefore, teacher education is important because we need good teachers. That's why teacher education is important, since the teacher is the main factor in effective teaching. Often teachers are blamed for the low performance. I'm sure you have heard about this, or if you are a teacher, you have heard so many blame coming towards the teacher. People blame teachers for the low performance of learners. Yet teachers are prepared by teacher education. I am in teacher education myself. I teach mathematics and mathematics education to people that are going to teach mathematics. And as a mathematics educator, I think the blame, teachers can have some blame, but the blame should not be only on the teacher. We should also look at teacher education. How are we preparing these teachers to teach? So the question which you can have, which was the title of my paper, is how can teacher education prepare teachers well enough to teach mathematics effectively and consequently improve learner achievement in schools? This is not an easy question. How to prepare teachers has always been a difficult question. My answer, I want us to learn from research. I think we cannot answer this question without learning from what research tells us about teaching and learning mathematics. In teacher education, there's a lot of work that has to be done within the time that teacher education has the student teachers within the program. What goes into the program is important. By that, I mean what courses are offered to the student teachers, what modules are offered to the student teachers, and what happens in that teacher education is important. And we can learn from research what can go into that teacher education program. From research, we learn that there are various types of knowledge that teachers need in order to teach mathematics effectively. It has been established that teachers need more than subject matter knowledge, meaning that if a teacher knows their mathematics, it's not enough. they need more than just the mathematics. Looking again at research, there was work from Schumann, which is seminal. I think all educators know about Schumann. He introduced the term pedagogical content knowledge. In simple terms, pedagogical content knowledge is knowledge of content in ways that teachers can teach to learners effectively. I'm sure people appreciate that sometimes it's one thing to know something, but it's another to teach it. So pedagogical content knowledge says it's about knowing the subject, in this case mathematics, well enough in a way that you can teach it effectively. And research has taught us the importance of paying attention to pedagogical content knowledge in teacher education. Schumann, when he was talking about pedagogical content knowledge, he was talking about teaching in general, not specifically mathematics. Now, some mathematics educators, Bo et al., extended the work of Schumann to describe the knowledge of teaching mathematics, and they call this mathematical knowledge for teaching. Bo and colleagues, they describe 6 categories of mathematical knowledge for teaching. 3 of them are part of subject matter knowledge, and 3 are part of pedagogical content knowledge. I'm showing you this, but I will not go into detail. I'm showing this just to show that what research has showed us is that the subject matter knowledge, the knowledge of mathematics in this case, also has 3 parts. And the pedagogical content knowledge in terms of teaching mathematics also has 3 parts. We have the knowledge of the curriculum, knowledge of content and teaching, knowledge of content and students, and for the subject matter knowledge, we also have those categorizations. I will not go into detail because we don't have time here, but my point is to say that there are many types of knowledge we need to pay attention to in teacher education. The research has showed us that there are many types of knowledge that we have to pay attention to in teacher education. In most cases, we focus only on the general mathematics and on teaching methods. And from the research, it shows us that these are just 2 types of the knowledge that we need to teach. There are other types of knowledge which you also need to teach. Some teacher education programs sometimes focus only on the pedagogy, and not so much on teaching. I can mention an example of our program here in Malawi. We have our primary teacher education program. It assumes that students already have the mathematics, and it focuses mostly on the teaching, on the pedagogy. Teachers come out strong in teaching methods in such a program, and yet they are weak in the mathematics they are going to teach. Similarly, if a program focuses only on mathematics, it can produce teachers that are strong in the mathematics content, but they will be limited in effective teaching skills of mathematics. What does this mean? What it means from research is that teacher education needs a balance of knowledge of mathematics and knowledge of teaching. We cannot have only one. From the research, one is not enough, and each type also has various forms. As we have seen from Bo et al.'s classification of knowledge, knowledge of teaching is more than teaching methods. This is usually the assumption we make in teacher education, that knowledge of teaching is just about the strategies, how to teach. But from research, knowledge of teaching is more than teaching methods. It includes knowledge of students, the students' prior knowledge, the students' languages, the students' misconceptions and errors. That's all part of the knowledge for teaching that a teacher will need to have. Now, if we look at our African context, the students' languages are often not the language of teaching and learning. We usually teach, in Malawi, we teach in English, which is not the language of the learners. I know in South Africa, you have English and Afrikaans mostly, but there are many African languages. So many children in our African context learn mathematics in a language that is not their own. This takes us to the next issue of my presentation, which is about mother tongue. The question I was asked to look at is, what is the effect of mother tongue in learning mathematics? Again, I think we should get answers from research. Mother tongue and learning of mathematics has been researched extensively in education, in the African continent, and also in other places. In South Africa, for example, SETATI has done a lot of work about learning using home languages. Again, when you look at the research, the findings acknowledge that learning mathematics in a foreign language like English presents problems to the learners. Learners who are not fluent in English, for example, struggle to understand the language and therefore do not access the mathematics. It is one thing, they are trying to understand mathematics, but the mathematics that is being taught to them is being taught in a language that they are not fluent in. Therefore, they don't understand the language and they do not get to the mathematics. As you can see, there are two levels of understanding here. There's understanding the language within which mathematics is being taught, and there is understanding the mathematics. So if we are teaching in a language that these children are not fluent in, they do not get past level 1, understanding the language. If they do not get past level 1, they will never get to level 2, where they understand the mathematics. A question we can ask is, what can be done to assist such learners? Research has shown us that seeing the students' languages as a resource rather than a problem enhances the students' learning. Seeing the language as a resource, not a problem. For a long time, people have seen mother tongue as a problem to students' learning, and sometimes insisting on English only because you see the mother tongue as a problem. But research has showed us that language can be taken as a resource rather than a problem. Language as a resource means using the language to promote learning. For example, code switching by both teachers and learners has been found to be effective. This is from research. Research in code switching has found it to be effective in teaching. By code switching, I mean where the teacher can switch from the English to the learner's language, and the children also can switch from English to the learner's language. I'm putting here where possible because I'm mindful of the South African context where there are many languages. The Malawi context is easier because usually the teacher and the children share a common language. So where that is the situation, it is not good for the teacher to insist explaining in a language that the children are not understanding. It's better to switch to the children's language and explain, and also allow the children to talk in their language so that the mathematics can be learned, other than insisting on a language that they are not understanding. So encouraging learners to discuss, maybe in groups, whenever they can discuss, explain something, or ask questions in their mother tongue when they are not fluent in the English, is something that helps in the learning of mathematics. I want to give a caution here that it is important to make sure that the learners understand the mathematics. I'm saying this because it's a common assumption that using mother tongue automatically makes learners understand mathematics. It's assumed that using mother tongue automatically makes learners understand mathematics. But using mother tongue does not automatically make mathematics understandable, but it makes the language of communicating the mathematics understandable, which is the level 1. We need the level 1 to move on to the level 2 of understanding. If you remember, we said there's level 1 where they understand the language, and level 2 where they understand the mathematics. Now, using mother tongue helps us to get past level 1. Now, as teachers, we need to get learners to level 2. Learners still have to learn and understand the mathematics in their mother tongue. I'll give an example of ratio. I think ratio is a concept which is important in mathematics. It is taught in primary schools. So it is one thing to understand the definition of ratio in mother tongue. So maybe you're teaching ratio and it's difficult to explain in English. The teacher can explain the definition of ratio in mother tongue. That will allow us to get the students past level 1. But it's another thing now for them to understand the concept of ratio from that definition in mother tongue. They need now to understand the concept of ratio. So the teacher needs to move with them from understanding the definition to understanding the concept of ratio. Often people stop at level 1, assuming that once you have defined in the mother tongue, then the mathematics is understandable. But we need to move beyond level 1 to the next level where they understand the concept of what we are defining in the mother tongue. This is where teacher education also comes in. Teacher education needs to address this part of knowledge for teaching. The knowledge for teaching categories I showed you earlier from Bo et al., one of them is knowledge of content and students. Knowing the students' languages and knowing how to explain in the student languages and knowing how to move them from level 1 to level 2 should be part of teacher education. Most teacher education programs do not address the use of mother tongue in teaching mathematics. And for that, teachers are left to find their own ways of dealing with mother tongue. It's not easy for teachers to go out not prepared and be able to move learners from level 1 to level 2. I believe that this needs to be addressed in teacher education. And so far, my readings about teacher education, very few do this. Many do not address the issues of mother tongue in teaching learners. We need teachers to be prepared to deal with this. And if we have good mathematics teacher education, it should prepare teachers to teach in the context which they teach in. Since I'm also in teacher education, usually we think that teachers will teach in an ideal situation. But we know the context of our schools, and it's important to prepare teachers to teach in the context that they are going to teach. And language is one of the issues in those contexts. My remarks, concluding remarks, I'll say we need to produce mathematics teachers of high quality. If we have to improve performance in schools, we need high quality teachers. And for high quality teachers, we also need high quality mathematics teacher education. Quality mathematics teacher education is teacher education that includes both knowledge of mathematics and knowledge of teaching, and all those aspects of knowledge of mathematics and the aspects of knowledge of teaching. Teacher education that pays attention to mother tongue of learners. As someone wrote, I read this somewhere, the quality of any education system cannot exceed the quality of its teachers. I'll read again. The quality of any education system cannot exceed the quality of its teachers. We can apply this to mathematics and say the quality of mathematics teaching and learning cannot exceed the quality of mathematics teachers. the quality of mathematics teaching and learning cannot exceed the quality of mathematics teaching. Therefore, if we want to improve the quality of teaching and learning, we need to improve the quality of mathematics teachers. And for us to do that, we need to improve our teacher education. Thank you very much for your attention.
Thank you. Thank you very much, Prof. Kazima. Please stay on the line because there are questions. There are questions for you, and I'll start with your question because we could be, now I'm looking for the question and now I can't find it. There is a question for you. All right. On the segment, this one is for you. This one is for you, Prof. Kazima. On the segment, Mauritius and Kenya are on top for most of the years. What could be the reasons for performing better? Prof. Kazima? Hello, Prof.
Yes, I don't have a complete answer to that. I haven't checked Mauritius, but I've had discussions with Kenya. In Kenya, they think the reason is because they have this project. I don't know if you know about SMASI. It's about strengthening mathematics and science in education. They call it SMASI. They started in secondary, and the secondary performance improved, and now they have it in primary. And they've had it for years now, I think since 2000. So they've had it for a long time. Teachers go for in-service education for workshops every holiday, where they discuss, they look at how to teach mathematics. And they think that that is why, since they started those in-service program for teachers and talking about how to teach mathematics, they think that's why their performance improved. That's what I got from talking to somebody from Kenya. I don't have complete evidence of that, just talking for somebody from Kenya. But Mauritius, I haven't been able to find out. Thank you.
Thank you very much, Prof. I think you said it and you explained it, but the distinction between moving from definition to concepts, I thought I understood you, but I'm not sure I quite. So if I'm explaining, I'm defining something, I mean, that on its own starts dealing with concepts, doesn't it? No.
Okay, in a way, yes, but not completely. Okay, I will take, let me take another example, maybe like proportion is a topic which is important in all of mathematics, understanding proportion. And
Right.
you can talk about what proportion is and define it in the mother tongue. But the whole concept of proportionality, you have to really understand what it means to make these quantities proportional, what it means to make the things you are dealing with in mathematics, whether they are numbers or they are other quantities, how can you make them proportional? That is the concept now. The definition can be understood, but now understanding the concept, the mathematics behind that definition is beyond just understanding the definition. You can see that's why even in the English-speaking world, you have people who have problems with mathematics, although mathematics is taught in their mother tongue. Because understanding the language is one thing, then you have to understand the concept.
All right. And you said something, thank you very much. You said something also about the use of mother tongue not making the subject easier, but making the language of teaching it easier. Again, I think I understand, but I don't think I quite get what do you mean by that?
It's the same thing I was talking about. I would like not to use the word easier. I was talking about understandable, that you can understand the language, but it doesn't automatically means you understand the concept. So my
Ah,
argument is that we, as teachers, we have to go beyond just telling them in the language. We have to make sure they understand the concept, not just stop at defining or explaining in the language, but making sure that now that explanation, they're using it to understand the mathematics.
I see what you mean. So you mean you,
Yes.
you are not going to be excluded by virtue of the fact that you don't understand the language. It will be the concepts you're not understanding, but at least the language won't rule you out from the get-go.
Yes.
Okay,
If we don't use, yes, because if they don't understand the language, they, even if they would have understood the mathematics, they don't get the chance to understand the mathematics because the language has stopped them from understanding the language.
All right. Thank you very much,
Yes.
Prof. Kazema, because I wanted to load the questions onto your side because the connection is always a hit and miss if we, in case we lost you before, but you are staying with the symposium, right? Because some questions might still come through the social media after your presentation. Yeah.
I will stay on.
Okay. Thank you very much again, Professor of Mathematics at the University of Malawi at the Zomba campus. Let's give a round of applause. Thank you. Thank you very much. We are still we're just going to take 2 or 3 minutes to direct some of the questions to Professor Dr. Sbia here. Okay, actually, they are not questions, most of them, Dr. Sbia, they are commendations. People think you should be Minister of Education. I will stand in the way of that, though. I will say, no, I would rather give you a center of excellence, national center of excellence for mathematics.
Oh,
you know, if we make you minister, we might start not having access to you.
Yes.
Because now your chief of staff will say, oh no, the minister is busy. I like the fact that children can look for you and find you. Yes. But Kagiso Trust is getting really a lot of feedback here on this. I'm looking for them. Pardon me. I'm not a technophobe particularly. Yeah, it was Teresa Muilo says you must consider that. Innovative methods definitely yield results. Thank you, Prof. Sevilla, for investing and being passionate about shaping the future of African children in stigmatized subjects. Yes, we can. And by the way, Sam Ramez said the question was not necessarily for you, the one about pure maths. So Professor Chweni has offered kindly to address part of the question asked by Sam Ramezi. You remember about the one about pure maths and that had me exposing my poor mathematical literacy. There's a comment from Linda as well, says, this is excellent. As a math teacher, you are phenomenal. I love the use of your hands to teach. So easy to see why you won the Best Global Teacher Award. Your passion for mathematics is contagious. Oh my goodness. Can your passion for maths replace coronavirus? Please. Please. So the last thing, the one that's the question before we close is, Doctors, we a great presentation and demonstration. What is your advice on classes in grade 8 to 10 where classes are rotating? I'm sure you're familiar with it coming from Josini. Yeah?
Thank you so much. No, to that, I'm sure it's because of the COVID, because of the number. But my advice is that, the rotation is fine to me to say, because in my school, what we are currently doing is that we allocate a week for grade 8 and also a week for grade 9.
Right.
However, we tried to make it a point that grade 10, 11, and 12 attend daily, because we want to ensure that, that there are no gaps there. Mm-hmm. So what we do, if we give, this week it's for grade 8, Then on the following week, if grade 9 comes, we make sure that for grade 8, we create the document which has like question and answers. So as when the grade 8, they are at home, they can work and they can also refer the answers from the document. So what is important is to give them the document with answers, because when you simply give them questions, in fact, they come back with the question unanswered. So it's very important to give them questions, and at the back, you provide answers. So as when they do activities, they can obviously refer. However, it's very advisable to just give the work which is based on a revision, not something new, because if it is something new, obviously they won't, in fact, try to answer those questions. So the questions for the week, while they are not attending, should be a revision instead of a new topic to say. Thank you.
All right, Dr. Svia, thank you very much. A round of applause for Dr. Svia and for Professor Messi Kazima as well. Okay, that applause is not going to win an award. Goodness gracious, I mean, what's wrong with you people? I'm not here. Okay, we're gonna move on. Somebody has got a mic. Oh my goodness, somebody has the mic on. All right, Dr. Svia, somebody has a mic on. They are going perpendicular to me now, like causing a clash. Hey, let's go parallel. All right, now it's not working. See why I don't teach mathematics. Okay, so what I'm going to ask is I want you see that song, that's Tatamia song that you did, man. Before we close, I'm going to ask, I'll need a 1-minute clip of, but now you see, you got to sing along as well. You see where I'm going? So I'm gonna take a video of him because we got to post this thing. So I want a 30-minute video. I'm going to rotate. I'm going to take a 360. That one I know, 360. So I'm going to take a 360 of him singing, but you must be toying with him. If you can convert toy into mathematics, and that will be. So I'm going to give you switch your mic. You do, when I stand in front of you, I'm going to video you, but I'm going to rotate to you all. You must show enthusiasm. When you do the enthusiasm, 30-minute video, all right? Start rehearsing. Get rhythm now. Don't let us down.
In fact, they can even sing with me because it's very straightforward. It's just that there is Zulu there, but I'm sure you can try.
What is the backup? What is the backup words? It's a long.
Yeah, okay.
Africans don't need any lyrics to sing a song.
Yeah.
They're going to get it right without the lyrics. I just want you to do, that little. I like it, so I want
to. I would sing the one of parallel lines.
You must count me down, say 3, 2, 1, and start. I want to hear the beat.
Okay. 3, 2, 1. Here alternator, ngobe parallel. Here alternate, alternator, ngobe parallel. Here correspond, correspond, ngobe parallel. Here cointer, cointer, ngobe parallel. Here alternate, alternate, oh, here cointer, cointer, oh, here alternate, alternate, oh, here correspond, correspond, oh,
Because in social media, if you're not trending, you don't count. That's my world. If we're not talking about you in the media, you don't exist. You might be the best thing that ever happened. So people at the end of the day must know who Dr. Severe is. They must know about Carrizo Trust, the symposium. They must know about this mathematics symposium. They must know about all these speakers. But they're not going to know it if you continue tweeting about those other suspensions and all that. If you retweet that stuff, you're getting in the way of mathematics. So let's retweet this video that I'm going to tweet now. Follow the Carrizo Trust on Twitter and UL Varsity. You'll see that video. You'll see yourselves in it. Retweet it until the whole Twitter is trending with mathematics. Thank you very much. All right, let's move on to, I'm getting carried away here. But you gotta get carried away to pass mathematics, right? All right, the next speaker is Professor of Mathematics Education here at the University of Limpopo. Again, another, I'm very proud because she was my schoolmate and classmate when I was here, way back. Still as friendly as she was, still as bright and as she, so the mathematics pedagogy, how that has evolved over time, and the link with teacher capability at school, and the link of mathematics with the fourth industrial revolution, or any disruptive technologies for future skills and or careers. That's a mouthful, but I can tell you if anybody can handle that mouthful, it's none other than Professor Kabelo Chweni. A round of applause for him. Okay, I have a real objection to your applause. That's not working. Thank you.
Okay, thank you for that introduction. And good morning, everyone. I'm going to try to answer the question about applied math and modeling and about pure math and modeling. And immediately that question was asked, I thought, this is what I want to talk about. Because the person who has asked the question is saying, I'm studying something that seems to be irrelevant. Applied maths, by its name, it's maths that can be applied. But here is somebody who's saying, how can we use this for modeling? And I think this answers the question. Should math evolve or should it not? Should we continue teaching it for its sake? Should we continue teaching it for its sake? Or should we try to make it make sense to the person who's learning it? And should we try to make it relevant for application? And that was the question. Back to my presentation, shall we look at slide number 2, which shows what I'm going to talk about? I'm hoping that through my talk, you'll be able to get the parts of the talk that I'm going to address. The first one will be about math pedagogy that evolves over time. I will not go into the philosophies and the histories of it, but I will address it from what happens in the classroom. I'm a teacher by profession, and I still teach mathematics. So I'll try to use examples of the things that most of us go through when we are in classes. And then I will pose questions around teacher capability, because for me, there's a big question around that. And then the last part will be to try to talk about these disruptive technologies that come in as we try to teach and learn mathematics. The third slide, please. If I were to ask, what is clear is that these kids are reading. The question is, would you find such in a maths classroom? And if you try to look at the maths classroom that you are in, or the maths classroom that you teach, do you allow them to sit like this? And the question will be, why do you allow it? And the other question is, when did this happen? Because when I was in school, we were sitting in rows. And what is it that we were communicating about what is being taught when we are sitting in rows? I remember even when we were sitting in rows, sometimes when we were given classworks, we would sit like this so that the person who's next to me should not see what I'm doing. So, and that has been the case for quite a long time. And then at some stage, it was like, no, you can't do that. Basically, the pedagogy was changing. You can't continue doing that. If we can move on to the third slide, you can't continue doing that. And what is it that we were trying to address as teachers or as people who teach mathematics and people who study what teaching and learning is? What is it that we were trying to achieve? Now, if you look at the third slide, when I was growing up, I think I would have been beaten up if I was sitting like that. And there are reasons why that was the case. Probably because I had to learn an algorithm and probably memorize, and I couldn't do that if I was going to be looking at what others are doing, because it deprived me the time to practice this thing that I need to know. And I would like to take you to what we were exposed to as learners in schools, and some learners are still exposed to this. And when I was preparing, somehow Fractions called and said, use me in your talk. There's this rule about fractions where if we're introducing a division, we say they are going to flip over and then you put multiplication instead of division. And many children go through that. If you have to multiply a number by a fraction, if you have to divide a number by a fraction, you know, you keep the first number, you flip around the other one, and you change to multiplication. And we survived, we passed, we did our matric, and here we are. But what did that mean? And I suppose when most of us were trying to understand what was going on, we were told that it is a rule. Yeah, even now, I think we still tell them that it is a rule. But what is that rule? Saying that it flips around and you put multiplication in between, is that the rule that we are trying to teach our learners? And that is why maths evolves, because we need to communicate this thing. We need to communicate ideas. We need to communicate concepts. And what is it that we were trying to communicate? What we are trying to communicate is that division by a number is the same as multiplication by the reciprocal. Can you imagine if this is what we were telling our learners? Division by a number is the same as multiplication by a reciprocal. And then if that's what we do, we are on slide. Are we seeing? Who's managing my presentation? We are on slide number 6. Okay, and that's the idea. We need to teach in such a way that we communicate the ideas, and our learners should see what we say being written. So if you're taking 3 divided by 4 as an example, according to this definition of division in this case, it is saying that it is the same as 3 multiplied by the reciprocal of our 4. and you can see it being written. And then you can extend that idea to numbers that are represented by variables. The first number being D divided by E, and the second number being F divided by G. So we keep in the first number, that's what we are supposed to do, and multiplying that by the reciprocal of F divided by G, which is G divided by F. So it becomes important that when you're teaching and teaching for communicating math, you communicate the math that the learners are writing. And then in the next slide, again, I like, as I say, when I was preparing, fractions called and said, use me, use me. If you look at addition of mixed fractions, many learners can follow this procedure. And if you ask them to justify what they are doing, they will tell you the procedure in words. They will not give you a justifiable explanation for what they are doing. And one of the reasons could be, at the time that we introduce this, we frustrate them. Remember, we have taught them how to add numbers, ordinary numbers, 1 + 2, 3 + 4 + 5. And when we were teaching them that, we never talked about multiplication. And then all of a sudden we introduce these other numbers. And then we want to add, but you're saying there is multiplication involved. What goes up in the mind of the learner? And that should be concerning us. When I was growing up, this was done. This was precision, you know, portable. But this portability of procedures is that meaningful to the learners. Shall we try to beam slide number 8? But sometime I was already working. I talked to a learner who was in primary and wanted that learner to explain how they do addition of fractions. And in particular, I was looking for this type in particular. And this learner showed me the steps. And then I looked at it and I'm like, wow. So yeah, I should go back to schools. These ones do not confuse things. They just talk about addition. They just talk about grouping like terms. And then there is addition, no mention of multiplication. Linking what you're doing currently with what they already know. What does it mean? And this is something that I think as teachers we need to think about. If you look at the example that is here, the red, those are like terms. You group them together, you add them together, and then you have fractions that are also like terms. And then you add them together, voila, you're done. But some of us, we won't tell the person that is sitting next to us. We weren't aware that 1.5 is 1 + ½ Don't tell the person sitting next to you that you're like, what? The other one that seems to be frustrating, and it still frustrates nowadays because some of the teachers are still using the same approach. The math that we did when we were introduced to multiplication of numbers that have got more than 1 digit, you know, we saw hundreds becoming units. We saw tenths becoming units, and you carry over. Do you remember? You carry over. You say 6 × 5 is 15, and you carry over 1. And I can imagine the learner sitting down and saying, but it's a 10, it's not 1. And you're busy saying, I'm carrying over a one. And again, our parents, that's what they did. They don't understand why we don't understand these things. They don't understand why these inquisitive children do not understand this. It doesn't make sense. Somewhere it just doesn't make sense. So what did this evolve to? It evolved to something like this. Why don't you just write what you are doing, that we are having 3 times 5, which is 15, and we are having 3 times 30, which is 90, and we are having 50 that is multiplied by 5, and we are having 50 that is multiplied by 30. And this is something that the learners can talk about. And they can talk about that even when they are in groups. They can correct each other when they are in groups. Unlike if you teach an algorithm that they cannot really comprehend. Because they're going to keep on telling the other one that, remember, we carry 1. And this person is saying, but it's 100. And you're saying you're carrying 1. That's what we mean when we say in the pedagogy of mathematics, the teaching and learning of mathematics evolve. And it evolves because we are addressing different things. Slide number 11, we are addressing different things. We are addressing thinking. People who are in maths education study thinking about mathematics. They study reasoning. They study agency, learner agency. You know, this class is where you go into, and then you say to the learners, sit in groups and start talking, and they just look at you like, what should we talk about? And then you go out and say, I taught them, but I want them to talk about these things that I have taught them. And they are not talking. Have we taught them to be capable beings? Have we made them believe that they are capable of doing mathematics? The other one is people studying norms of interaction. Are these interactions that you are having with the learners, how mathematical are they? Do you study them to see whether the interactions that are happening result in mathematics learning? And what do you value? What becomes an excellent interaction? And then you have people who study discourse. Again, discourse in mathematics. And I think to a large extent, we should be thanking people. I will say, be thanking people, not mathematicians. And I've got a story attached to that. We should be thanking people who are in maths education because they started addressing issues like this thing that we are studying is not transparent. And we're representing it on the board, but are the ideas carried by how we do this representation? And then does these representations support efficient communication and use? And when I'm talking about this, the representations that do not support communications, you can imagine the books that we are using. And Tatesibia, when you do introduction to functions in grade 11, where you study the effect of parameters on functions that are represented graphically. You know, the book will represent all these functions on one picture. And you expect the learner to discern that and make sense of it. And the mind is saying, I'm confused. But teachers continue doing that, regardless of the free technologies that we have. There's a lot of free softwares that we have on the internet that can be used for that introduction. The maths educators questioned things like generalities of the things that we do. How do we generalize ideas? Do we see structure in the things that we do? Do we develop learner structure sense? These representations that we use, are they clear? Should we always use symbols, or should we sometimes use graphs, or should we use words or use numbers? When I studied calculus, the introduction was about the gradient, the gradient, the gradient. And then when I started teaching, there was a challenge. You had to go back to the basics. You couldn't teach an idea without going to its basics. And the other challenge was, can you represent this idea in different ways, in words, in numbers, graphically, and then symbolically? And then we sat there, and I was working with Ntatemasha at the time, and we were like, how do we get around these things? And at that time, reform about how we teach and what we teach was robust, and it changed. What you see in the books now, where you introduce limits using numbers that are close to a neighborhood, it's because of this evolving pedagogy. And then questions like, how close are we to the exact value, issues relating to precision? And I said I have a story that relates to these issues that I'm talking about, and it relates to how I became a mathematics educator. When I was an honors student, I was the top student, and deep down, I knew that there were things that I didn't understand, like this person who's saying applied maths and modeling, pure maths and modeling. There were things that I did not understand, but every time I wrote a test, I was going to get a 75 and above. And that started haunting me. And then you go home, you talk alone, and you come to class, you're so lonely because these things that you are doing, you can't talk, you can't discuss them with the next person. And the explanations that you give are vetoed by somebody, not necessarily us who are the students. You know, every time a question is asked, we look at the professor. We don't look amongst ourselves to say, is there an answer that is going to come from us? And I talked to my professor about that, the lecturer at the time, and I told him the truth, that I know that I'm going to pass, but I don't understand these things. And he said, you know, there is a discipline called maths education. Maybe that's what you should study. And the question becomes, was it a justifiable response? Was that justification for the loneliness that I felt? And so you can imagine the loneliness that learners are feeling when they are in class trying to do mathematics. I told you that the fractions were calling me. I teach calculus, and somewhere I need to revisit what was done in school because of the challenges that I experienced, because my students are not able to sometimes connect what we do with what they have learned. And one of them is similar to 2 and 2/15. So what does that mean? And do we teach that? Do we teach its representations in different ways? And when I was in school, I don't think I was aware that these were different representations of the same idea, because things were taught in isolation. This representation at the top, right? You hardly get that. It is in books, but do we talk about it? Do we talk about it as saying something about the remainder? because 2 and 2/5 is the same as remainder 2 in this context. But is this what we teach our learners? And then if that is the case, if this is really the case, what is it saying in terms of the evolving maths? We need to, in whatever we are doing, try to draw connections, try to bring context into what we are doing. And also know that we are preparing our learners for the grades that are going to come. We are preparing them for the math that they are going to do at university, because here they are at university, they are in my class, and the same idea that they are supposed to have learned at school is still challenging them. And we are at slide number 15. The same idea that they are supposed to have looked into critically is required of them when they come into university. I once asked my students to integrate the function gx divided by 3 plus 7x. And I said that this function is equal to x squared subtract 2x plus 4 remainder -7. And you can imagine what they did. They said, but you didn't give us gx. Why didn't you give us gx? And there is no need. All they need to do is to interpret the right-hand side and rewrite it, represent it differently. And its representation is x squared subtract 2x plus 4 subtract 7 divided by 3 plus 7x. And you know, sometimes when this happens in class, you're caught off guard. To say, but these people have done divisions at school, they have done remainders. What is the problem with interpretation of remainder -7? We don't teach connections, but maths has evolved. We are saying that if it doesn't make sense to them, they're going to run out of your class. It has got to make sense. And having said that, what does that mean about teacher capability? And when I saw this question, the first thing was to think of Punambatra, because she talked of capability deprivation amongst teachers. You know, you said teachers are having a problem with Euclidean geometry. I once asked my colleague, what is the problem with Euclidean geometry? And he said, there is no problem. Dr. Spias is saying there is no problem. And when you talk to teachers, they will say, I didn't learn it at school, or they will say, we don't address it at workshops. And usually I'm like, what does this mean? You are a teacher. Why would you expect somebody to come and workshop you on a maths topic when you can read? I don't understand that. If you've done a little bit of maths, you can extend that to a new topic. So, but the system has taught our teachers that they are dependent. The books that we are using, the books that we use, you know, you prescribe a book, you go to school A, they're using the same book, school B, same book, no supplementary resources. And you're like, how do they survive? And then when they have to go on holidays, you call them to become learners. And what do you teach them? And we don't question those things. What is it that we do when we are with teachers during in-service training? If they're saying, I don't understand Euclidean geometry, why don't you teach them how to read text on Euclidean geometry? Because for me, by the time you qualify to become a teacher, it means you can read a math text with comprehension. Then the other thing is that our teachers are not knowledge developers. You know, you can teach the same thing for donkey years and you realize that learners do not understand a thing, but you keep on doing the same thing. But we don't study the things that we do. If you were in teacher education to say to the students, I need you to write a narrative of what you did in class, they will look at you like you are crazy. And every teacher is supposed to be able to do that because you want them to be able to notice what happened. You want them to analyze what happened during class. You want them to reflect on what happened during class. The question is, do we teach our teachers that that is important? Do we incorporate that into our programs? We want them to develop their PCK as Messi has been doing, but how is that developed? If they cannot talk amongst themselves and waiting for somebody to give them a workshop, how does that then develop? You talk about teacher noticing what is happening in class, but you never get them to talk about that which happens in class. How do they improve? How do they develop their own knowledge of what teaching and learning mathematics is? When teachers exchange ideas, they will be talking about results. No wonder we always research performance. They don't talk about negotiation of meaning. The dialogues that are there are not about the subject areas, except during workshops. And outside the session of the workshop, it's not math, it's something else. We don't teach them to elaborate the concepts that they teach. And then the other thing is just listening. You know, listening to the other teacher and listening to the learners. Listening is very challenging, very, very challenging because it is purpose-driven. So when you're asking learners questions as a teacher, what is the purpose? What are you trying to really do? What is it that you're trying to do with the answers that they're giving you? And usually we say, let the learners compare the solutions. And then you say, Deborah, answer the question. Martha, yeah, and then Lydia, you're waiting for one who's going to say something that meets your expectation. And then the other learner is like sitting there and saying, oh, my answer is not appreciated. They won't talk again in your class. They will be quiet. It is these wrong answers that tell you their understanding. And those are the things that they need to, those are the things that we need to capacitate our teachers to do. And then collective writing, as I indicated, when I was growing up, there was nothing like collective writing. You work on your own and then you become surprised when you become a journalist that these things that you write have got to be vetoed by a group of people and they rewrite. And you still get people, I think even at university it happens, where somebody says, I've done it, and you can't comment on it. Because you were never taught in your maths class that we work together. You were never taught in your math class that your ideas can be criticized. Because what did we teach? Precision that is given by an expert mathematician, forgetting that that mathematician had to do the spade work. They had to work somewhere before they wrote the book. And our learners are thinking that mathematicians are these people who got all the answers, and they don't. They work on problems till they drop. And these are the characteristics that we need to see from the learners and our teachers. And then once we have done that, we can then talk about teacher capabilities. The title suggests that I talk about the fourth industrial revolution. And I like this question that was raised by a first year student taught by another lecturer. And he wrote the lecturer an email just before they were going to write a test. And he said, "Doctor, since there are literally softwares on the internet that can differentiate and integrate, practically do everything with full steps. They can compute limits to drawing graphs. Are you saying that we're going to write online when we will be accessing the answers online?" Because the student is aware that we don't have proctored softwares, and most universities don't. Then the question becomes, how are we going to assess them? Why are we assessing them if the answers are online? And we are doing that. Last year's group passed their maths, and some of them, they copied the answers from the internet. I'm not talking about UL students. I'm talking about countrywide. That's what happened. Then the question becomes, if this is the case, what math should we teach? How should math evolve? Because it has got to evolve. The pedagogy of math has got to evolve. Our focus has got to be different. And do we have an answer as mathematicians? Probably not yet. I think by now we hate all these software engineers. Who has done this? Previously, we could, in our private spaces, look at these solutions and look at different questions and give them to students to sit for in a face-to-face exam. But currently, that is not the case. So what? And these softwares are doing the same with physics. They're doing the same with chemistry. So what is the way forward? And here is another person saying, we are doing maths. We are told that maths can help you model. Are they doing modeling? For those of you who are aware of L'Hopital's rule in limits, how many of us were examined on the same ideas using graphs? We were always given a symbolic function and we will do a few steps and then we got the answer. But because of this email, this year I thought, I'm not going to assess my students that way. They have done limits at first year. They have learned graphs. I'm going to examine, to assess them based on graphs. And believe you me, it is not, they are not happy. There's a student who's in the audience. He greeted me in the morning and said, "Ma'am, what are you doing to the third years this year?" And that question is loaded. What are you doing? And maybe those are the discourses that we should have as people who are teaching mathematics and expecting our learners to learn, to say, where should the torch be? And with that, I think we can move to the last slide. This is just summarizing what I was trying to do. These are the skills needed for the fourth industrial revolution. And I think I've tried to talk about all this during my presentation. And can we afford not to do what I have been suggesting that we should do? And my answer is that if we are not doing that, we should know that that is an epistemic injustice. And this brings my talk to the end.
Thank you very much, Prof. Chweni. I just remember just the rule, you know, the rule was a problem. It was, my teacher once told me, and he put it in not so too. We're trying to ask the similar question. He said, he tried to explain and we still didn't understand. Tried to explain, we didn't understand. He said, hi man. Immediate. So I didn't think about it's almost the answer you got. This guy is saying, just swallow this thing as it is. When you are a teacher, you'll understand it. The contradiction of that. Swallow it as it is. When you are a teacher, you will understand it. Well, how am I going to teach anybody if I don't understand it? And would I want to teach something I don't understand? Not a chance. Guess what? We ended up teaching. So the fact that mathematicians could be replaced by machines is a good thing, because then we will know exactly what the concepts are. The excitement, Prof. Chweni, is that people who were very intelligent were not allowed to be human. So you could not be the intelligent Kabelo Chweni and now have problems about understanding concepts. What's wrong with you? You are passing. Everybody wants to get your mark. So what are you doing? What do you want me to do? Because you are the top student. But these are all the issues of pedagogy, that when we teach, we have to understand not just the subject, but the people we are teaching. But the point that I'm taking with me was the wrong answer quote, that when you ask learners a question and they give you the wrong answer, use that as a reflection of their level of understanding. So use it to teach yourself about where the people you are teaching are. And when you understand the level where they are, then you can help them to rise to the higher level. Not ignore it, because you are right. If everybody is talking about the other, that's why when we tweet, we mention who's asking a question on Twitter. We mention who sent a message, because people are interacting partly to share the info, but partly to get recognition for their effort. So thank you very much. Unfortunately, we will have to move to the next question. People are asking, I'm a subject advisor in the Free State. We would like to invite Dr. Svia for something. So they are asking for your contacts. Will there be a recording that will be shared with those who have responded? I suppose there will be. Yes, thank you. That is the answer. And there are many other questions that I cannot deal with now. We'll do that when we have to the open, because I need to get the last presentation in so that we can finish by 12. Otherwise, we promise people to log on and we will be done by 12, and by 12, we're still rambling on. It doesn't work. So we have to make sure that by 12, we have done every presentation. So allow me to please just put some questions and comments on our bands, and then we will deal with them when we are done with the next presentation. We have been listening to teachers and professors and experts. How about we listen to a learner, somebody who has just written mathematics at matric level? But he's not just any person who wrote matric. He's someone who wrote the matric and became a top mathematics learner in the year 2020. And his name is Daniel Holtz. He's going to talk about how to learn and study mathematics, the impact of a positive attitude. So let's give a round of applause from the Western Cape, Daniel Holtz.
Hello. Good morning.
Good morning, Daniel.
Good morning. Thank you to the KD Symposium for an opportunity to speak here today. I would like to share a few slides. Right, can I begin? Yes. Okay. Is the presentation on?
Yes, you may proceed.
Right. Good morning, ladies and gentlemen. Today I would like to share with you my attitude and passion towards mathematics, and a few of the methods that I use to learn and study for mathematics. First of all, a little bit of background. I grew up in Hermanus in the Western Cape. It's about 100 kilometers east of Cape Town. It's quite well known for whale watching in the tourism industry. So if any of you have visited, you'll know about it. I attended primary and high school in Hermanus. Both were Quintile 5 state schools. Personally, I enjoyed high school far more than primary school. They were a lot more open and encouraging towards the activities you chose to pursue, irrespective of what that was, even if it wasn't A-team rugby or something similar. I've been interested in mathematics for almost as long as I can remember. I think most of it is due to the exposure and encouragement that come from my parents. Both of them have a great passion for the field. And in particular, my father works in a field that is related to mathematics, so it helps to have someone who can help you when you struggle. Another important thing, throughout my school career, I attempted to take part in as many mathematics Olympiads and similar opportunities as possible. On the one hand, to try and develop my problem-solving skills, and on the other hand, I find it fun. It's nice to solve problems that, on the one hand, look difficult and sometimes look almost undoable, but then step by step, reaching an answer, whether that's right or wrong. Well, I get a kick out of it. Then another very important part, I've had a few very good teachers throughout my school career. They were able to teach the mathematics in a way that showed their motivation and their passion for the field. And they were able to convey that in such a way that the learners who they taught could pick it up and could approach mathematics with the same passion and motivation and keep working at it. To put it short, their passion fueled my passion, and I was able to enjoy the thing and approach it with a positive attitude. Right. Another important topic which one struggles with no matter who you are or how good you are with the subject, or in most subjects, to be honest, is the topic of motivation. Why do we do mathematics at all? Why do we bother attempting a difficult problem with the knowledge that we might not be able to solve it? Well, the answer to that lies in how you are motivated to do mathematics. And to be honest, that differs for every person. A few of the things that motivate me to do mathematics is, first of all, there's a certain satisfaction of a job well done. When you do a problem and you see there's one step and there's another step, and it becomes clearer and clearer as you go along, it's quite fun, and you get a bit of an adrenaline rush from it. And once again, it doesn't really matter in this case if you reach a right answer or wrong answer. The fact is you follow the method, and that gives you a bit of a kick to go on to the next one. Then it's also quite important, I think, to have someone behind you who you know is willing and able to help you when you struggle. It's really quite demotivating when you get stuck on a problem and sit for hours and not make any headway. So just knowing that there's someone who, if you've tried all the options and nothing seems to work, you can go to for help, it really does help for motivation and encouragement and to keep going. Then somewhat of a practical motivation. And a good ability in mathematics is required for, well, most technical careers and quite a lot of other careers as well. So your ability in mathematics will likely open or close doors for you. It's an important thing that you have to pay attention to, and thus it motivates you to give your all. And to put it shortly, keeping a vision for the future of where you want to get with your mathematics, I think really just helps to keep you on track and to keep you going in the right direction. Then the topic of studying mathematics. Usually this is somewhat abstract and it's difficult to directly speak about because there's not usually that much content to study. Usually it's more a matter of understanding the work. And if it was a subject like history or geography, that's a different matter entirely. Usually the most important thing when you try to learn mathematics and study for it, I think, is understanding the basic or the fundamental principles. They are the building blocks on which everything else is built. If you struggle with them and you try to do some of the more complex stuff or the stuff that builds on those principles, well, it's a relatively futile exercise. Then, of course, to achieve that understanding, you need to pay attention in class. And really, that's a lot easier than trying to struggle on your own through a textbook after class when you haven't paid attention. Just listening to a class offers an audio and visual opportunity to engage and find interest in the work. And if you struggle, you can ask questions. As opposed to like we had during the pandemic when we stayed at home, that wasn't all that easy. Right. Then a few more things when you try to learn a particular method, maybe try and figure out why that method works and how it works rather than just memorizing a couple of steps. In the long term, you remember what you understand and you forget what you try to memorize. And then one other part which many of my peers and I sometimes struggle with a bit too is the matter of homework. It's just one of those things, you have to do it. It's where you get the practice. It's where you show yourself that, yes, you do understand the work. And then when you do the homework and you do get something right, then celebrate your success. Go outside, run around a bit, just do something else. It all helps with motivation and encouragement and being able to go on to the next thing. Then the general thing, I think it's quite useful to attend a program like AP Mathematics if something like that is available. Even if you don't fully understand what is taught there, the exposure to some of the more advanced or more complex mathematics, I think on the one hand develops problem solving skills, and on the other, that exposure sort of shows you where the work you do in class can be or is headed. So it once again helps with maintaining a vision of where you're going. It shows you what the direction is and it helps to keep you motivated. Then the other somewhat of a important topic, I think, is past papers, if they are available. Sometimes it's a bit tricky in grades before matric, but if they are available, I do suggest past papers. On the one hand, they help to get you used to the work and the level as well. And sometimes some of the problems offer rather interesting lines of thought to just help to understand the concepts better. Then something which I feel personally about, look for practical ways of applying the mathematics you do in class. How you do this will likely differ from person to person. Personally, I enjoy electronics projects and systems related to that, and I attempt to apply the mathematics in that. I do that as a hobby, and it's something that I enjoy doing, and it's a reason to keep going with the mathematics. Then for tertiary study, I'm currently enrolled at the University of Stellenbosch. I'm studying for a degree in electrical and electronic engineering. The reason for this, as I said previously, is that I enjoy designing electronic circuits and building electrical systems as a hobby and implementing them in related projects. It's once again, mathematics is quite a large element in that, and you need a fairly strong background in mathematics for a degree like engineering, and I particularly like electrical and electronic. In a message to some of the students who are currently studying mathematics and perhaps struggling with it, an important thing to remember is that one day when you have finished school, it doesn't matter what degree you choose to pursue or what you choose to do, you will use mathematics in your day-to-day life, whether it is with shopping or doing your finances or having to interpret your house plans one day, you will use it. So the stuff you do now is not in vain. The better you understand it, the better you'll be able to do it when you have to apply it one day in your life. Then just something for the now, remember that mathematics is a continuous process. Even if you don't quite understand something today, you might understand it better tomorrow or the next day. So the effort that you put in day by day will be worthwhile, and just keep going at it. That said, another very important thing which I feel is sometimes a problem among my peers is the matter of using your time effectively. It's a very important thing, and it has led to the success or the downfall of many students, and I've seen it happen quite a few times. Then just a few practical applications of the mathematics which appeal to me personally, as I've said with the electronic projects. These are two photos, one farther out and one in detail, of a quadcopter project, which I assembled with my father. But the idea is, once again, you have the quadcopter in the air, it's trying to fall down, you have to calculate how much thrust goes to each propeller, and to ensure that the thing remains stable. So once again, there's a lot of mathematics in that, and it's just a way for me to apply what I have learned in school and to enjoy it. But of course, this will differ for everyone. You just need to find some or other practical thing that you can get hands-on with to develop your understanding of the mathematics and get to grips with it. It's a fun way of doing that. Then just one more project, a self-balancing robot. So the idea is the box keeps trying to fall over, and then the wheels have to move it into position. Once again, a lot of mathematics is required to solve the problem of doing that. But the same applies. It's just a method of applying the work and enjoying it and having some fun. Just one last word. You should remember, Rome wasn't built in one day, so build your future brick by brick. Thank you.
A round of applause for Danny first. Thank you, Danny, for the wonderful presentation, and may you succeed in your electronics engineering, because we want to meet you now when you are a top, what is it, an award-winning electronics engineer.
Thank you.
I'm going to ask two learners in the room, because we are really out of time and we still need to hear from our chairperson here. Can I have the learners in the room ask questions, please? One or two? You can't suppress yourselves. Okay, do we have a learner with an answer? With a question? Yeah, you might as well have an answer. Okay, there's one there. Please go ahead.
Okay, so my question is...
If you don't identify yourself and your school.
Okay, my name is Sarah Mamavula, and I'm from the Kalimiso High School, and I'm in grade 12. So my question is, what kind of books, or actually I have two questions if I continue. So my first question is, were you able to study or practice mathematics every day? As we all know that mathematics should be an everyday subject. So were you able to balance mathematics with other subjects, or like, if yes, how did you manage it?
Personally, that is somewhat of a difficult topic, if everyone can hear me. But especially during the pandemic, when we were at home.
Okay, Danny, hang on a second, Danny.
Yes.
Just taking the last question here.
Gotcha.
My name is Papi Witness and I'm from MP Mamabulo.
Can you take your mask off, my child, please? I couldn't hear your name.
My name is Papi Witness and I'm from MP Mamabulo Secondary School. I'm doing grade 12. My question is, how can you manage time when you are studying mathematics, and how can you be able to study all those content? You said you have to study the first content, then at the end you will manage all the content. But my question is, how are you going to manage those content, and how are you going to balance the time?
All right, you got the question, Danny?
Okay. I'll do the first question first.
I mean the last one.
Okay. Yes. Okay.
All right. Please answer them crisply, and we move. Thank you.
Okay.
Witness, please switch off your mic. Yeah.
Regarding the first question, balancing everything is quite a difficult topic. Of course, it is necessary to do to put in enough effort in your other subjects as well in extracurricular activities. Personally, I enjoy jogging as a way of getting away from the work, but I think that really everyone needs to find their own balance with what they enjoy doing to really take a break. And regarding the other subjects, once again, generally one puts in effort depending on which subject you enjoy the most. It really depends. But yeah, balancing everything is quite a challenge, especially during the pandemic. Actually, to continue doing extra activities and to prevent just you're just staying at home all the time can be tricky. But I think having other people around who are there to motivate you on the one hand and to help you on the other really does help. Okay, can I go on to the next question?
Yes, please.
Managing everything, or managing all the content is tricky. In my experience, relative to some of the other subjects, there's usually not that much physical stuff that you need to study, as you would say history or a subject like that. Usually, once again, it mostly just comes down to practice, and that takes time. So really you need to work out a schedule for yourself to say when will you do what, and to enable yourself to do as much as possible with the time that you have available. But once again, time management is important, balance is important, but there are difficult subjects, and really you need to find a way of bringing everything together effectively. But yeah, I hope that helps.
All right, thank you. Thank you very much, Danny. Let's give a round of applause to Danny Holtz. I need to give our chairperson a chance to make closing remarks, but I give 1 minute or two to Prof. Chweni, because there were two questions that came for her that if she could just respond. One was, as she's looking at them, how will 4IR affect the pass rate of mathematics in rural areas? The second one was, I'm a fourth-year student. If you're saying every learner's answer that's wrong must be used to get a thinking behind the answers, what if there are 5 or 6 learners or so? How are you going to be able to do that and still manage the time, manage the pace? And so I guess they're saying we have 45 minutes for a period. Can you do that? So please just do that. And I think, Chairperson, if you could come here, because yeah, I'll move so you can use you can come through in the meantime as Professor Chweni is then I'll introduce you once you've taken your seat. Prof. Chweni, please crisply.
Shall I take the second question first? When you're having learners in class giving wrong answers and you have to address them within limited time, the question will be, by not addressing those questions, what is it that we are trying to do? Because the answers that they're giving are saying, I don't understand, so learning is not taking place. So if we're saying that a period is 45 minutes, I cannot address these answers, are we saying that we're going to continue teaching when learning is not taking place? And you need to strike a balance. This doesn't happen every day. On some days, you will find that it's maybe 3 questions that you need to address, or maybe 4 questions that you need to address. And addressing them may also help those who are silent and not talking in class. So this is something that we need to balance. And issues of time management in class need to be questioned. When we go to class, the intention is for learning to take place. If learning is not taking place, you will finish teaching what you are supposed to teach, but the learners will never finish what they are supposed to teach, to learn, I'm sorry. And then the second one has got to do with the effects of the first industrial revolution and the pass rate of mathematics in rural areas. And I appreciate this question because it touches on issues relating to social justice, but I'm not going to respond to it addressing that, but address it by saying curricula has got to be revised. And it has got to be revised in such a way that it addresses the skills that are needed for the fourth industrial revolution. And if you do that, if you teach for those particular skills, when the learners go to the world of works, they'll be able to cope. I'm going to use communication as an example. You can't be having a quiet class and then expect this person to, as an employee, be able to articulate their ideas. Thank you.
Ladies and gentlemen, it's now time for the chairperson of Kagiso Trust to give a few remarks in closing.
Thank you very much, Program Director, for this opportunity. You know, currently the world has got a number of problems, a lot of them. Africa as a continent has a lot of problems. South Africa as a country has a lot of problems. And at Kagiso Trust, we try and approach the societal challenges. We gather like-minded individuals and like-minded institutions to deal with these matters of public interest in finding collaborative solutions to make the world a better place. There is a saying that says, if the world throws at you lemons, what do? You make lemonade. Therefore, the problems will not be going away soon. What innovation says is that there may not necessarily be new solutions, but we can take old solutions, repackage them, redo things differently in order to promote new solutions that are innovative in solving societal problems. You know, this has brought us to this thought-provoking symposium, which we are really dealing with the problems of mathematics teaching and learning in the country, in the continent, and globally. We would like to develop skills and professional teachers that can actually assist in producing members of society. Remember, the learners are going to be members and leaders of society, but these are leaders of society that can then solve socioeconomic challenges. I'm always of the belief that mathematics is just not about solving for X. No, it's about dealing with societal challenges. You can solve for X as much as you want, whether it's in a simple equation, whether it's a quadratic equation, whether it's any type of equation, but if you are not able to solve societal problems, then solving for X will not exist. It is not today my task is not to really talk about mathematics. We could go on the whole day, but my task today is really just to thank and acknowledge the people who have made this a success. To start with, I would like to comment that it is the first in a series of Kagiso Trust Mathematics Symposium to come, and this grand opening through a valuable partnership we have with the University of Limpopo. You know, I think it was 3 years ago when Kagiso Trust approached the University of Limpopo to, form a partnership. I mean, you know that universities are not just for teaching and learning. Universities must solve societal problems. Now, if Kagiso Trust is attempting to deal with societal problems, the universities should be our go-to institutions in forming partnerships. When Kagiso Trust approached the University of Limpopo for this partnership, it did not take a week. Within days, the university said, yes, you are a partner that we can form a partnership with. And on that note, we'd like to thank Professor Mokhalong, who did not hesitate and accepted our request, and again, to co-host the symposium. We are very appreciative and thank you so much, Professor Mokhalong. I'm aware that Professor Mokhalong is not here with us, but there are representatives from the university. We are very thankful for that. And to top it all, the registrar of this university is a mathematician. How many universities have a registrar who's a mathematician? It's really encouraging. So we would like to really thank Professor Masha, who's a mathematician in his own right, and who gave us some very interesting opening remarks about the teaching of maths in an African university, pursuing African solutions. What are the support structures? And in asking those questions, the university ultimately put together a research program whereby PhD students are investigating these issues. We like so much, we are so colonized that we start looking for solutions outside the African continent. And I must say thank you very much to the University of Limpopo and to Professor Masha for having thought about those African solutions and thinking about how the teaching of mathematics on the African continent can actually bring about those African solutions. And then again, I'll move on and thank the Deputy Vice Chancellor, Research, Innovation and Partnerships, Professor Jessica Singh, who welcomed us with warm hands and accepted our request for research partnerships 3 years ago. Professor Singh has supported all initiatives. We have 4 initiatives with the university, that is Kagiso Trust together with the university. We co-hosted a joint seminar on education in the 21st century with the Thabo Mbeki Foundation in 2019. We also had a longitudinal study of the Kagiso Trust educational model under the Beas Nodia School Development Program in Sekhukhune. It's led by the University of Limpopo, Professor Temani and the team of lecturers there. And I am convinced that going forward, we are going to have many more. The challenges that we deal with as Kagiso Trust are many, and we will form further partnerships in trying to deal with these problems. Today we learned about many ways of improving interest in mathematics, how to best teach and learn mathematics. In addition, we have learned that the use or importance of mathematics in different professions is in finding solutions that will make the world better. One of the things that was interesting this morning was to be reminded that in everything that we do, mathematics is involved. Everything, when you wake up in the morning and you look in the mirror, those who do, you're dealing with mathematics. When you open a tap and you take a shower, it's physics, but there is mathematics involved. When you walk up or down the stairs, it's mathematics involved. Let me just take an example. When you're walking up a flight of stairs, normally they are of the same height going up. If one of those stairs is higher or lower, what happens? You miss your step, which means that you have programmed height. And what is height? It's measurement. What is measurement? It's mathematics. In so many things. When you come from an optometrist and you have a new pair of glasses that have changed from the previous ones, do you walk properly? No, you don't, because height has been distorted. All sorts of things. I will not go into that. Those are for the professors and the mathematics teachers, but I'm just appreciating what we learned about this morning from Dr. Sibia. And I was really, really impressed by that singing and, making mathematics interesting to our children. Why is it that we use songs when we go to war and we don't use and you don't use those songs when we teach mathematics? We are so quick to use song when we go to war, which is something that is not, it's not productive. So let us look at those basics that Dr. Sibia talked about in terms of the teaching of mathematics. We are very grateful and we are very proud of you, Dr. Sibia. We are extremely proud of you for, representing the positive that South Africa has produced, not what the program director talked about this morning about gender-based violence, this and that, violence, corruption, theft, and so on. We have produced a mathematics teacher of global recognition. And then I'll move on to Professor Messi Kazima, our friend from Malawi, who we are thankful for technology that we were able to connect. Otherwise, she would have had to fly from Malawi expensively, spend 6 hours trying to get here, another 6 hours driving from Johannesburg to here. But we connected, and her topic was very interesting because she talked about, some things that we take for granted. Talking about the teacher, the centrality of the teacher in mathematics education. There are so many other dimensions that she talked about, but she has confirmed what we have always said in Kagiso Trust, that the teacher is central in the teaching of any subject for that matter, the centrality of the teacher. A teacher of high quality and a teacher who understands the children that they are teaching. And then the issue of mother tongue came in. When you have learned things at school and you get home, you don't want to lose the trend of what you have learned at home, at school. But if you are not able to interact at home in a language that is being used at home, what you have learned at school then stays at school, doesn't come home with you. That is the truth. And she talked about that importance of language, understanding language of instruction. If you don't understand language of instruction, what can you learn? Because the door has been shut in your face simply by language. So I think those are some of the things, my colleagues in Kagiso Trust, that when we develop programs and together with our other partners, that we should be looking at and involving them in our programs. The program in Kenya, we've always talked about why are so many of these African countries ahead, other African countries ahead of South Africa in maths and science. And that program that we talked about, I think we are going to follow it up and find out exactly what is happening in Kenya. We are thankful to Professor Kazima for putting that forward to us. And then Professor Kabelo Chweni, I really enjoyed the examples that you made, especially when you said mathematics is beyond numbers. People are scared of numbers. And I think we should start saying mathematics is teaching and learning mathematics beyond numbers. We should teach skills that could be used to solve emerging challenges. Now she talked about issues of communication versus rules. We come from that environment of rules, which communication, you don't even ask why, you just follow the rules. 2 times 2 is 4, 4 times 4 is 16, and so on and so on and so forth. How do you get there? We did not ask, we just crammed and got it right at the end of the year. And now we are caught up with that cramming and reciting, because now we can't reason, we can't communicate. And I'm thankful that Professor Chweni, your teaching is beginning to bring in communication versus rules, and bringing about justification versus procedure. It came out very clearly, and it's really an eye-opener. It's really an eye-opener for those of us who started school during those days of rules and procedures. And then our student or our learner, he's no longer a high school learner, is now a university student in electronics and electronic engineering. Danny Hoos, thank you so much for making time and agreeing to share your experiences with mathematics. Congratulations again for being South Africa's top mathematician and achiever of 2020. You know, despite the school closures and so on, we still have kids who really performed, you know, way above expectations. You have showed the learners in the audience in the symposium and those attending virtually that developing a passion or love for mathematics is not that difficult. Once you adopt a positive attitude in anything, once you adopt a positive attitude, it begins to come automatically. And it's not everybody who will get 90%, but if your attitude is good, if you are a 40%er and your attitude is good, I can assure you, you will shift that to a 60. And if you've been a 60%er and your attitude is good, you shift that to an 80%. So really that issue about attitude is very important. And about practice. Do your sums, do your problem solving, practice. Some you'll get wrong, and then you'll ask others how they got them right. But practice, whether you get them wrong or right, as long as you practice, then it works you practice once, you get it wrong, you practice until you get it right. I would also like to thank my team at Kagiso Trust, the CEO, Mema Nkodi Muizi, and the officials for making sure that this inaugural Kagiso Trust International Mathematics Symposium is a success, as it has been. I'm sure all of you can attest to the fact that this symposium has been a success. But again, the success we'll detect it further as we go along and we start practicing and bringing into our everyday lives and teaching of mathematics some of the principles and methods that we've had about today. Again, I would like to thank our patrons that are attending virtually. Mayor Bongiwe Njobe is one of them attending virtually. We have our trustees, Ndate Gulam Abubakar and Ndate Tabiso Ratsumo. Maybe some joined later and I'm not aware of them, but some of them I know will follow later on Facebook. They will find recordings and they will follow this up on Facebook and on Twitter and so on. Thanks to all those who attended, all the attendees that participated virtually within the country and on the continent and outside the continent. And I'd also like to thank our facilitator, Dr. Victor Homiswana. You did an excellent job and I can see this task is your daily bread. You are passionate, you are really passionate, about, what you do. And I know the University of Limpopo is your alma mater, but I don't think it is a major reason you made this symposium as interactive. It is because of your character and your ability. And I wish to wish all the participants and everybody who's here and those who are attending virtually good health, and let us continue to be ambassadors for mathematics. We need more learners in high school enrolling for mathematics and more mathematicians across various fields of study. And I didn't mention my colleague who is here with me, Dean Zoe Nebutalo, who is, many of you who are teachers, lecturers, and students in Limpopo will know that he was once head of department in the Department of Education in Limpopo. I'm correct, yes. And he is still very passionate about education. And I think we should take advantage of such people in our communities. There are many. Some of them are retired teachers who have now gone into government. Some of them are now lecturers at university. Some have gone into administration. But I think we should still take advantage of that. And I'm sure that the next Kagiso Trust University of Limpopo International Mathematics Symposium will be a success. And we will be going to another province. And I'm sure our colleagues, Prof. Masha, you will join us when we go to other provinces to go and tell them what happened here. Thank you very much. And God bless.
We must also thank you, Chairperson, Ms. Mangoni Nsaba, the Chairperson of Kagiso Trust. The event has now come to an end. Sorry, we went a little over by 8 minutes. In my industry, that's an unforgiven sin because it means people would have missed the news at 12. It never works. But I appreciate the opportunity to have been part of this. Thank you very much to our speakers, both those who are here and those who joined us virtually. And thanks to you as delegates who joined this virtually. And we appreciate the fact that you did that. It's because it's my alma mater. See, people are going out with fake qualifications. So because these are my former schoolmates, I wanted to just make sure, sit with them, sound intelligent. Then people know I really studied here. And so let's just close by saying this. There's a book called Talent is Never Enough by John Maxwell. Talent is never enough. And in it, he mentions 13 choices that people must make to turn their talent into making themselves a talent plus. So this is very important, especially to you learners who are here. Just listen to this. If you don't understand what I'm saying, image, image. All right. So what John Maxwell says that we know you have talent, but you can't become a talent plus person without the following things. Number one, he says your belief will make sure your talent is not limited. Number two, passion will energize your talent. Number three, initiative will activate your talent. Number four, focus will direct your talent. Preparation will position your talent. Practice will sharpen it. Perseverance will sustain it. Courage will test it. Teachability will expand it. Character will protect it. Relationships will influence it. Responsibility will strengthen it. And teamwork will multiply it. So thank you, Kagiso Trust and University of Limpopo for your teamwork. When we talk public-private partnerships, that's what we mean. Thank you very much for joining us. And what I'm saying after this doesn't involve those who are joining us online. It involves those who are in the house here. And that is that lunch is served just outside the room. If you're all with us, you can have your virtual lunch. Sorry. But lunch is served just outside here, everybody, so don't leave. This is Africa. If you leave without eating what we are giving you, we will take it personally. And we will tell everybody that you are uncultured. So thank you very much. See you at the next symposium. Thank you. Thank you.